Welcome to the eLab midterm project. We're going to implement the DC power supply. The following is our schedule. The first week would be a basic demo, which you should have completed the basic functions and ready to demo to the TAs. Then, the second week is the advanced demo. Complete any additional function for your circuit and solder your whole circuit on a PCB board. There are two ways to hand in your report. If you choose to hand in the proposal report and the project report, you'll get bonus points. The due date for the proposal report is this, and the due date for the project report is this. However, if you choose not to hand in the proposal report, then your project report due date is this. The following are the spec of our circuit. The power supply must provide positive 12 volt and minus 12 volt, along with tunable function to provide 5 volt to 12 volt. You must also note that the output voltage must be stable for resistive load ranging from 1 kilo ohm to 100 ohm. We will test this requirement by doing the LOR test. The requirements for advanced circuits are the same as basic ones, only that you have to solder it on a PCB. Any other functions that do not harm the basic circuit are welcome to implement. You will get bonus points if it is well designed. These are some functions that are often seen on the DC power supply. You should test your output voltage with the following method. These are listed on the Word file. And this is the form for the LOR test. We want you to understand the current which the regulator IC could provide has limit. Basically, you will see that in this column, the current is not performing well. Therefore, we will only use the values from 1 kilo ohm to 100 ohm to calculate the LOR. Notice that you should measure the 7805 under the 5 volt output and with different resistance. The 10 ohm here is also the limit of the IC. When using low resistance, the current is high, therefore producing large power. If you use regular resistor, then your resistor will burn. Use the Siemens resistor that could withstand high power to prevent this. The following is the circuit of the DC power supply under the LOR test. Remember that you should never solder the load resistance on your circuit. This is the schedule for the advanced demo. Basically, we will demo 12 teams per hour. Therefore, if you're the 13th team, you should be able to demo in the second hour. If no one is waiting to be demoed, and the TA are waiting for your demo, then we have the right to record that you haven't finished your lab on time and deduct some points. We may provide the registration form for the demo in course, but remember that if you register, means that you are able to demo. If we find out that you actually can't, then we'll also deduct some points. We will test your results and compare with your report during the demo. Here are some notices. Our lab will not be available at weekends. And find the TA in office 217 to assist you if you find the lab not available in other times. And remember to turn off all devices before leaving. The welding tools are provided in lab, but only one set per class, so cooperate with others to use it. When implementing the power supply, remember that safety first. Try not to get electric shock from the power supply, and some devices could be extremely hot while working. Also, the capacitor must be connected correctly. Long leg on positive side, otherwise it will explode and your circuit is ruined. Do not short circuit the power, otherwise the whole lab might lose electricity. And beware of your resistor size and current to prevent from burning or melting. The following is the design flow of the DC power supply. Using the transformer, we'll obtain the voltage from the AC line. Then apply the diode rectifier, and then filter, and finally the voltage regulator on the circuit. You can see the electric signal changes in each stage. The voltage regulator will be implemented with a stabilizer IC, which looks like this. Notice that different IC has different pin configurations. 7812 has in, ground, out, while the 7912 has ground, in, out. I know it's disturbing, but please blame the company for this. Please don't blame us. I think we talked about these requirements before, but just make sure your circuit meets the requirement before you start weld your PCB. For the advanced function, once again, any function is accepted, but you must discuss the following things in your report in order to get your bonus scores. Some ideas are listed here just for your reference. If you don't know what you could do in the report, here is a suggestion. Include a simulation result of your design. Now, we'll briefly talk about the welding tools that you'll use. This is called the soldering iron. It is extremely hot when you plug in the power, usually between 200 to 300 Celsius degree. So be careful and always unplug it if you don't use it. When you unplug it, clean it with a wet sponge to remove the solder on the soldering iron. Then put it into the stand we provided. This is the solder. The material will use the soldering iron to weld on the PCB. And this is a desoldering pump that could suck the solder from your PCB when you find out that you've made mistake. We'll not use other materials, so I just skip them here. When soldering, think about which component of the circuit should be soldered first in order to ease your process. Usually we'll start to solder from the components that are relatively low height to those have higher height. That's all for the midterm project. Good luck.